Start talking our way through the bell word. What degree is this polynomial here? 3. We count our x's. I've got 1, 2, 3 x's, so we are in degree of 3. Is that even or odd? It's odd. What information does that tell me now that I know that that is odd? Is it? Is that a new bell? Yes, it tells me the direction on my ends. Are they going to go the same way or opposite way? Opposite way. And going opposite ways. Positive or negative leading coefficient? Negative. Right here, I see that negative sign. So that means a negative leading coefficient here. What does that tell me about my graph? Right side goes down. Now I just need my x-intercepts. I need my zeros. How do I find the zeros? Equal all of these sets of parentheses to 0. So I have x plus 4 equals 0. What would I do to that one to get the x all by itself? Subtract 4 from both sides. So I get what? X equals negative 4. I'm going to come over here and put an x-intercept at 1, 2, 3, negative 4 right there. And then I take x minus 3 and I set it equal to 0. What do I need to do to that one to get the x all by itself? Add 3 to both sides. So I get x equals what? X equals positive 3, yes. And last but not least, I have x plus 2 equals 0. Negative 2, can I subtract 2 from both sides? Absolutely correct. We're going to pop that up here. What do we know about our ends? They go opposite directions. How do I know which end does what? Right side goes down. If they go in opposite directions, the left side goes up. And we're going to go all the way through these x-intercepts. So all the way through and loop to the next one. All the way through that one and loop to the one in the front. All right, last bell word question. Oops. Go. We want to know how many imaginary roots this polynomial has. Well, how many total roots does it have? 5. 3 equals the total number of roots. So if the degree is the total number of roots, I know that the real roots plus any imaginary roots that we have would have to equal my total, which is the same thing as the degree. We know our degree is 5. What else do we know? What else did they tell us? It has 3 real roots right here. So I'm going to put 3 in the place of real. So 3 real roots plus my imaginary roots equals 5. What number could I put in there for the imaginary roots to make a true sentence? 3 plus what equals 5? 2. So we have 2 imaginary roots here. One last reminder about homework. Tomorrow is the absolute last day that I will accept any and all homework assignments. That does include your bell work that you just finished up, probably turn that in today at the end of class. And that does include your homework packet / review packet that you need to turn into me tomorrow. I would not encourage turning that in today, so you have that to study with tonight. Turn it in tomorrow, right at the beginning of class before you take your test. If you're worried that you're gonna forget it and you're not gonna remember to turn it in, you might want to turn it in today, but I would highly encourage you to keep it with you, use it to study, and then turn it in tomorrow right before you take your test. The rest of our time today, I will spend answering any and every question that you guys have. I will tell you in advance that I did go over all of the questions in this period because I had enough time to get through every single one, so not in order. I have posted that video. That being said, one thing I do want to tell you guys about the videos is when they made me switch out my computer for a new computer and they made me switch out my iPad for a new iPad, they took away my old tool for how I used to record videos. And how I have to do it now is through Zoom and screen sharing and all these things. And sometimes these aren't talking nicely to each other. So sometimes when you go to watch the video, it's not capturing what I'm doing on the screen. You can hear me talking, but you can't see what I'm doing. That is something that is unfortunately outside of my control to fix. So if you go in to watch an old video and that's what's going on, many apologies. Maybe just turn it on with the audio and then open up the notes, because I do post the notes a page at a time, just like I have up here. So you would at least be able to see the things that I've written, you just wouldn't be able to see me writing it in real time. So again, guys, I'm really sorry about that, but I don't have any other things to use right now, but I'm giving you another one. So, what problems would you guys like to see? Yes, sir. Absolutely, next. What problems often review? Yes, sir. Number 6, absolutely. Number 6 was one of the ones, or was the one that I had asked you guys to change on the homework. Instead of all possible positive real zeros, we changed it to just maximum and minimum. How do I find the maximum? How do I find the total? Highest degree, yes. So we're going to look at the degree of the polynomial. In this case, that's going to be 4. So my maximum is 4. For minimum, it depends on whether it's even or odd. What is our minimum for even? Here it is. 0, none. What is my minimum for odd? 1. Is this an even degree or an odd degree polynomial? This is an even degree polynomial. So my minimum is going to be 0. What else would you guys like to see? Number 4, number 3, absolutely. Number 3. To determine if something is a factor, I'm going to use synthetic division. So I take that x plus 2, I set it equal to 0. And I put that inside of a little box. When I go to write the numbers that are outside of that little box, what's the first number I should write down? 1. Because that goes with x to what power? X to the 3rd power. Beautiful. Okay, so I have x to the 3rd power. Then I need the coefficient on x squared. What's the coefficient on x squared? Look, -1. Coefficient on just x? -16, and my constant. -20. Notice you guys told me we were degree 3, but I just wrote down how many numbers? 4. If I was a degree 2, how many numbers do you think I should write down? 3. If I was a degree 7, how many numbers should I write down? 8. I should always write down one more number than the degree. And if I don't, then that means there's a missing power of x, and I need to substitute a 0 in there for. We'll look at one like that here after we're done with this one, but I want to make sure you guys are aware of that. Chop this guy off from everybody else. We're going to start just by trying to determine whether or not this is a factor. So I'm going to bring that 1 straight down. -2 times 1 gives me what? -2. I add that to the value up above. What do I get when I add those two together? Get -3. When I do -2 times -3, it's 6, and I add that to the -16 up above to get what? -10. -2 times -10, +20. What happens when I add that to the value up above it? I get 0. What does that mean that I've got a 0 as my remainder? It is a factor. This is my factor theorem. The remainder equals 0. Therefore, x plus 2 is a factor. Then they wanted me to find the remaining factors. So I'm going to use these numbers here. I have 1x squared minus 3x minus 10 that I need to find the factors for. I'm going to do my area model. Do my x. So I have a up here and c down here. X squared -10. I can multiply a and c together. So I multiply 1 and -10 together. So I need two numbers that multiply to give me -10. But when I add them, I get my b value. What is the b value? -3. Well, what numbers do you know that'll multiply to 10? 5 and 2. If I add 5 and 2, though, I get 7. I want to get -3. -5. So -5x and +2x. Look at 2 boxes at a time now. What can I take out of x squared and -5x? Can't take a 5 out of both of them. What do they have in common? A 1 what? 1x. What about down here? 2x and -10. What can I take out of both of those? What do they have in common? 2. Positive or -2? +2, because it's touching a box that's positive. This 2x over here is a positive, so I take out a +2. Then we're going to go vertically. X squared and 2x. What can I take out of both of those? I can take an x out of both of those. -5x and -10. -5. Great. So I'm ready to write down all of my factors. What was the factor that I found at the beginning? x plus 2. And the factors that I just found over here from factoring that were x minus 5 and another x plus 2. So there's all of my factors. Can you guys help me find the roots? Equals -2, x equals 5. And what would my last one be? -2 again. When this happens, when I have two of the exact same roots show up, we call that a double root. What would happen is that on the graph, I would see a bounce happening right there. We didn't have the opportunity to graph any of these, but just to give you guys a little bit of a visual of what's happening here. -2 would be right here. +5 would be over here. Did we have a positive or a negative leading coefficient when we began? Positive leading coefficient, the coefficient was 1. What was my degree? 3. Is that even or odd? That's odd. So we have the right side that goes up, but because it's odd, what's the left side doing? It's going down. Well, somehow I have to connect these two. If I take this one up, it's going to have to bounce here. If I take this one down, it's going to have to bounce here. Where that double root happens is where I would see a bounce happen. You guys will not have to graph one that has a bounce. But I did want to show you what it looks like when we have two of the same roots fill up. I do want to go and look at number 4 briefly. You guys want to work all the rest of the way through it? We can. But I'm going to use synthetic division on this one. Because they asked me, is this a factor? What goes inside the little box? -2. What are the numbers that I need outside of that? What's the first number that I need? 1. And that goes with x to what power? X to the 3rd power. Then I need x squared. Where's x squared? X squared isn't there, right? Because that -3 has just an x squared. I have a missing power of x. I have x cubed, but I don't see x squared in there. Yes, sir. 0. Then my -3 and my 2. This one again, this goes with x cubed. This one goes with x squared. This one goes with just x. And this one is my constant. I will tell you guys that tomorrow on the quiz, there is a problem. And there's supposed to be a 0 right here for one of your x's. Because you have a power of x missing. So please be watching for that. Look for all your powers of x. Here, I knew there had to be a missing power of x because it was x cubed that was the biggest. And we said that you should write down how many numbers if you have a 3rd degree polynomial. And write down 4, but they only gave me 3 numbers to work with. So I knew there had to be a 0 in there somewhere. You guys want to finish working through this one, or do you want to go look at something else? You want to finish this one? All right. So I'm going to bring that 1 straight down. -2 times 1, I get -2, and I add that to the 0 up above, so that just stays -2. -2 times itself gives me a +4. What happens when I add that to the -3 up above it? We got a +1. -2 times +1, I get -2. When I add that to the value up above it, I get 0. So the fact that I got a 0 means what? I have a factor. This is a factor. Supposed to say factor, but kind of screwed up. Now it's like a factor. All right, so I have x squared minus 2x plus 1 that I need to factor. I'll draw my area model, my box. What's going on here? A and C. Now I need to multiply A and C together, and B goes by itself at the bottom. So x squared and 1. I need two numbers that when I multiply them together, I get 1. But when I take those same two numbers and I add them, I get -2. -1 and -1. -1x, -1x. What can I take out of x squared and -1x? They both have x's. What about -1x and 1? What do they have in common? 1, positive or -1? -1. But remember, it's touching a box that's got a negative sign with it here. X squared and -1x, what can I take out of both of those? Take an x out. And -1x and +1. -1. So my factors. We found at the beginning that x plus 2 was a factor. Now we just found x minus 1 and another x minus 1. So what are my roots then? Yep. X equals -2. X equals +1, and x equals another +1. What do we call that again when I have two of the same? Double root. What would it look like on the graph there? What we're seeing happening? Yep, it's gonna bounce off the x-axis right there at 1. What else would you guys like to see? We did 3 and 4. What else would you guys like to see? Number 9, absolutely. So number 9, similar to the bell word. I know that the real roots plus the imaginary roots equals my degree. What is the degree of this polynomial? 4. So it has to be equal to 4. What information did they give me to work with? It has 2 real roots. So I'm going to put 2 in the place of where it says real right here. So what number could I put in there where it says imaginary that would make that a true sentence? 2 plus what equals 4? 2. Since we're right here in number 10 is almost the same. You guys are using number 10. Real plus imaginary equals my degree. What's the degree on this one? 7. I put that in for the degree here. What else did they give me? 2 imaginary roots. So I'm going to put 2 in the place of where it says imaginary here. Whatever I put in for the real roots plus 2 has to equal 7. Well, what can I put in for where it says real? 5. What else would you guys want to see? Number 11, absolutely. So number 11 says we're supposed to do factoring by grouping. And whenever you see this word grouping, what shape should you draw? A box. I'm gonna draw my area model, draw that box. Do I need the X with this? No, why not? How many little squares do I have inside here? 4. How many terms do I have? Also 4. The only reason I need the X is when I have 4 little squares, but only 3 numbers to put in there. What has to go here in the upper left? 4x cubed. What has to go down here in the lower right? Negative 27, we've got a constant down in the lower right. For these 2 middle terms, does it matter which box I put them in? Nope. First one and last one matter, the other 2 don't. So 12x squared and negative 9x. All right, 2 boxes at a time. I want the biggest thing that these 2 have in common. What can go into both of them? I want to take it out of both of them. I heard 4, I heard x squared. Down here, biggest thing that can go into both of those, because I want to take the biggest thing out of that. Negative 9. So there's a factor. Now we're going to switch gears and go vertically. 4x cubed and negative 9x. What can I take out of both of those? Take an x out of both of those. And 12x squared and negative 27. What's the biggest thing that I can take out of both of those? 3. Positive or negative 3? Positive 3. All right, so I have x plus 3. I have 4x squared minus 9. Are those both fully factored? Which one can factor more? 4x squared minus 9. Does anybody remember what we call this kind of a special situation? Difference of 2 perfect squares, yes. And so the difference of 2 perfect squares here. What would I multiply by itself to get this first perfect square? What would I multiply by itself to get 4x squared? 2x. So 2x goes in this one. 2x goes in this one over here because I'm going to multiply them together and I multiply those factors together. What about 9? What would I multiply by itself to get 9? 3, but I want negative 9. Negative 3 and positive 3. I want 1 positive and 1 negative so that when I multiply them together, I get a negative 9. The directions said, find all roots. How do I find all the roots from here? Set them equal to 0. X plus 3 equals 0. 2x minus 3 equals 0. X plus 3 equals 0. All right, looking at that first one. X plus 3 equals 0. How do I solve this one for x? Subtract 3 from both sides. Negative 3. What about the one in the middle? What do I do to both sides? Add 3 to both sides. So 2x equals 3. Is that my final answer? What do I still need to do to it now? Divide both sides by 2. So I get that x equals 3 over 2, or what would that be as a decimal? 1.5. So far I have 2 of my roots. I've got this one. I've got this one. We've got one more. What do I need to do to this one far on the right hand side? Subtract 3 from both sides. (2x equals -3), and then what? Divide both sides by 2. If x equals -3 over 2, or that would be the same as -1.5. Where's my last root? What else would you guys like to see from the review? Example. Number 7, I don't think I did. Nope. What is the degree? 3. X here, X here, X here, so we have degree 3 polynomial. What does that tell me about my graph? Opposite ends. Where do I look to know what the ends are doing? Whether they're going up, down, which one goes up, which one goes down? Right side, where do I look for the right side information? Leading coefficient, is this one positive or negative? Negative. All right, let's write down our intercepts. X plus 3 equals 0. Where will my x-intercept be? -3. X minus 2 equals 0. Where will that x-intercept be? +2. And x minus 4 equals 0. Where will that x-intercept be? +4. So -3. +2, +4. What did you tell me the right side was doing? Going down. Why? Leading coefficient is negative. What's the other side doing? Going up. Why is the other side going up? It's odd. Yes. Do we have any double roots? Are any of these repeats? No. Then we go all the way through the x-intercept. No bouncing. So I'm coming in from the top, it has to come out the bottom and around to the other one. And out the top and over here. What else would you guys like to see? You said number 5? Absolutely. Let's find, I want to know how many total solutions we have. That means real and imaginary together. Where do I look in the problem? You know, how many total? Look at the degree. What is the degree on part A? 4. So that would be my answer. What about on part B? 3. That's it. We're done. We have about 5 minutes left, which is enough time to do maybe one more problem depending. You guys have anything that you would like to see? One thing I definitely want to take a moment to point out is that on problems like 3 and 4, where I had x plus 2, that's when I take it and set it equal to 0 to find what I put into the box. That's when they were asking me, is this a factor? On problems like number 1 and number 2, they asked me to use something called synthetic substitution. That means what I get is what I put right in here. I don't set anything to 0, I don't change the sign, so it's synthetic substitution. And it has an F and parentheses. Just grab that number and go. So for example, number 2. Number 2, part A, what number would I put in the box for my synthetic division? -1. What about on part B, what would I put inside the box here? -2. And how did you know to do that? Yeah, it has F and a number or G and a number. It says synthetic substitution. Grab the number and go. If you see X plus something or X minus something, that's when you have to set it equal to 0 to figure out what you're going to specify that box.